Yeah. So this program is primarily going to be focused on kind of introducing the AI workflow, as well as kind of a couple basic AI models and applications. And to do that, I would like to direct your attention to these Zoom screens and introduce our wonderful professor advisor, Professor Xin Liu from UC Davis. So, Professor, take it away.
Hi, everyone. Thank you for having me here. My name is Xin. I'm a professor in the computer science department at UC Davis. And thank you for giving me the opportunity to talk to you over Zoom today. So let me give you a quick introduction about AIBridge. As the name suggests, AIBridge is meant to bridge the gap between AI and whatever topic that you are interested in. So we started this program in Davis in 2022, and then brought us to Cornell and UIUC this year. We also had 2 such camps in public libraries in California. So among all these events, and Jack was with us at Cornell University, we've taught 100+ people, probably close to 200 now, and with very diverse background, from high schooler, home makers, to IT professionals, to postdocs, graduate students in food science, health, and so on. So the motivation for us to start this is, well, AI has caught the attention of the general public recently, and many people want to understand what it is and what can they do with it, either as an understanding or maybe using this in their work and so on. So we designed this camp specifically for people who are outside of computer science and trying to get a basic understanding of what AI is. So in this weekend, you probably hear about some basic machine learning algorithms through the usage of Toolbox, so to get some hands-on experience. We hope this will not only share with you the basics, give you an overview of what's possible in AI, but also help you to take further learning courses. For example, there are so many wonderful courses on Coursera and so on. You can continue to learn if this really interests you. And hopefully this will help you have easier time to communicate with or collaborate with computer scientists or machine learning researchers. So with that, the first question might be, well, what is AI? Artificial intelligence, machine learning, or you might also heard the word artificial general intelligence. So I'm wondering, when I ask this question, if this is something that might be on your mind. I have to say this caught the entire world, including computer scientists, by surprise on how good, how well it did, and how much attention, how many users it has got, how fast, how quickly it got. So I'm sure everyone probably have used it once here or there. So instead of asking what is AI or machine learning, really what we could ask you is, well, what we could ask is what can AI do? So in a very, very broad view, we could say AI will take some data as input, then give you some information or data. If you think about ChatGPT, you might be saying, well, what would be some machine learning algorithms that I can learn to start with? It will give you some answers, right? You might also say, can you help me design a 2-day trip to Bentley, right? So it gives you some information. So that's kind of a very, very intuitive view. But if we break this down a little bit, look at algorithms a little bit. So this is roughly what we can classify machine learning algorithms or AI to. So there are roughly 3 big categories. I have to say there are smaller pieces are not included here, but big pieces are what we have listed here. The first one is called supervised learning. So as the name suggests, what supervised learning does is it gives you so-called label data. And those label data will help you, help us train the machine learning algorithms, then predict outcome or future. So for example, we all probably know, well, now machines can do computer vision tasks. If you give a picture, it may tell you this is a cat picture, or this is a dog picture, or this is a house, and so on and so forth, right? So the way it is learned is so-called supervised. So when we are training the machine learning models, we give the machine learning models the images, a cat image, and its label, say this is a cat, or just called a cat, or a dog picture, then the label dog. Then we supervise the algorithm using these label data. We supervise the algorithm to learn. Okay, later on, we can give it a picture. It may identify, oh, this is a dog, or this is a cat. So this is called supervised learning. Supervised learning is still the largest group of machine learning algorithms. I would say probably 90% plus of algorithms used in real world are based on supervised learning. So we'll cover quite a few algorithms in this class. Then on the left corner, you see something called unsupervised learning. Well, as the name suggests, it's unsupervised. That means we don't have labels. So that means we may have data like images, a lot of images, but we are not saying telling the machine each image what is a cat, is a dog, and so on. So in that sense, the algorithm doesn't get direct feedback. The way unsupervised learning is used is often to find hidden structures. It has been used very broadly in, for example, bioinformatics, in social science, and so on. So for example, if you think about Facebook group, right? Facebook may be able to see, oh, this person has a connection, or send a lot of message between this person and another person. And maybe there's a group of people who send a lot of messages to each other, or they are friends with each other, right? We may or may not know what group they are, but we can find such group structure. So for example, we may later on find, okay, there's a group structure among people in this classroom because we send a lot of message to each other. We are in this class together, right? So it's often used to find hidden structures, and also used for dimensionality reduction. In the sense, if you have a very high dimensional data, we try to reduce it. We'll introduce some algorithms in this category as well. Then there's a third category called reinforcement learning. So this is something where it's more complex, and we're not going to cover in this class. So I'm going to give you a little bit of a detail of explanation of what it does. So reinforcement learning really comes from, well, how humans learn. Positive reinforcement, negative reinforcement, right? So for example, the goal of this is to do algorithmic decision making. So for example, let's say you are trying to play a chess game with a computer, or you are going to play a computer game, say Dora with computer, right? And what's behind the scene is often reinforcement. We can design a reinforcement learning algorithm to do this, to play chess, for example. So the way it does is, like human learns with positive reinforcement and negative reinforcement, the algorithm will get a reward system. We will make certain actions. So for example, playing chess, I put a piece in a certain place. Maybe this piece got lost. Eventually, after a game, I win or lose, right? So that's a reward. And the goal is to learn a series of actions so that the computer can play the chess game well. And it is doing this by the reward, whether you win the game or you lose the game. This is very much similar to how human learns. So you might also heard a word called deep learning. So deep learning could be any of the previous three categories that I talked about. The reason it's called deep is, well, we might have the word neural network or neurons. Our brains are made of neurons, right? So deep network is basically, the deep part is basically saying I have a lot of layers of neuron, kind of kind of on a high level think about, okay, in our brain, we have a lot of neurons and some neurons will fire together. There are connections like the links here. So deep neural network basically means we have a lot of such layers. You could have thousands of layers, hundreds of layers in such deep network when it's really deep. So this is where deep learning comes into the picture. Again, as I mentioned earlier, for supervised learning, unsupervised reinforcement learning, we could also use deep learning architecture. It's an algorithm, what's behind the scene. So going back to this, I want to give you a quick overview of what we are going to cover. So, So the big picture is artificial intelligence, or some people now call it AGI, artificial general intelligence, to really be like human being, make decisions like human being. Then within that, many people will consider machine learning is what we cover, machine learning algorithms. And within that, there's deep learning, which is a special case of machine learning. What we are going to cover in this class is this area. We're not going to get into deep learning. We're going to cover some classic machine learning algorithms. It's easier to start, it's intuitive, and it builds a foundation for us, any of us who want to learn more advanced AI or machine learning algorithms. So hopefully that's clear what we're going to cover. As I said earlier, we have taught this class to very diverse people with very diverse background. So I'm going to give you a terminology alignment sheet. And this is a sheet Jack will share with everyone. So feel free to come back to this if you are more familiar with other terminologies. So what we use most in this class is what we call sample, or sometimes we call it data. It usually composed of features and the label. So for example, if you want to say predict the GPA of a particular student, right? You may have certain features saying, oh, which grade the student is in, which classes the student is taking. These are considered features. And the label will be the student GPA. And putting this together, we call it one sample or one data point. For the word feature, there are many ways to call it: independent variables, attributes, predictors, and so on and so forth. I'll let you read it. For the word label, there are also people call it dependent variable, outcome, target variable, etc., etc. And for samples, people may call it cases, observations, participants, data points, and so on. So again, this is for us to get on the same page in terms of the word terminology we use. So a couple of suggestions on how you can make the best out of this class, right? So this is a typical practice in machine learning or in general in computer science, I would say. Very often, you start with to find the example of what you want to do. You read through it, you understand it, and you try it. You may modify it. Then for pieces you don't understand, you can Google it. Or nowadays, you can also ChatGPT it. So these are the basic skills, and we are going to help you practice and learn a little bit more in this class. And for this particular class, I would say the best way to go is to ask questions and type along during lectures if you could. Ask for help, make good use of the lab. We have lectures and labs interleaved together, and really make good use of lab. Provide feedback. You can tell, okay, we're going probably too fast or we're going too slow. And what parts are helpful, what parts are not. I would like to mention, given there are so many materials out there, why are we still doing this in person, right? I would say this slides tell us why we are still here. For many people that I have taught or worked with outside CS, the very beginning piece is very challenging for them. How to set things up, how to get things running. If something is not running, why is it not working, right? And very often, for beginners, it may take a really long time to figure out. And in this class, you are doing this with us and you are giving assignments, labs to do. So really gets hands-on experience. And with Jack and his friends here, you get immediate help. This is the most valuable thing you can make good use in this class. And along this line, we definitely focus on learning by doing. In most classes, we'll use AIBridge dataset as example. And for the assignment, you will use AIBridge dataset to do a demo, then the wine dataset to do your assignment. You are welcome to explore your own dataset or your problem as well, of course. And in the last page, I'm going to just list a few resources. Class notes are all available. And if you need some refresher on Python, there's a very useful link. sklearn is what we're going to use, and you are going to see this a lot. Google as always, and now you can also use ChatGPT to help. I have an asterisk there saying, well, don't trust everything ChatGPT tells you. Understand it, verify it before you use it anywhere. So this is a quick introduction. I hope you really enjoy this class and have fun with it. Thank you.
Thank you so much, Professor. All right, so
I'll say goodbye and sign off here. You guys have fun. Thank you for having us here.